Well, I'm on my, I don't know how many days. It seems like it's been weeks, but it's been a while on the same thing. Okay, we have these trucks um, for elongated tenders. They're mimic of the Hudson and the Northern side view, at any rate. And I made them using 3D printing, and I made them so I could use them on my trains, which I like long tenders, excuse me, because I like to put electronics in them, and so I need more space. The last one that I built with Leon's help, we actually put a fan in it, so it kept cool. It's pretty exciting. Anyway, this whole exercise started when I made 3D printed trucks a long time ago of the freight cars and stuff, and they used the same design for the tenders. And I put these eyelets in. I got those from oh God, Ed Golden Hands, and and uh, and with that eyelet, I can pick up energy on the axle, which that was good. Um, and I also had wheels, had metal wheels, and I made an insulator to keep the axle. I had cut the axle in half, put the insulator in there, and I had what I called all-wheel pickup. Every wheel picked up power. You didn't have just two wheels in the front and two wheels in the back, one on the right, one set on the right, one side on the left, but all wheels, all wheels of this picked up power. And that really got me going, because my engines would stop as I went through a switch. If one wheel was dirty and the other wheel was in the middle of that switch, your engine would just stop. Sometimes it changed direction if you're going really fast, or it just go to neutral if you're going through the switch. But at any rate, so I've been working on this and how to do it, and my original concept was using wire, and it seemed like people were just didn't want to form the wire. They thought it was too complicated, and I somehow I tended to agree. I kind of wish now that I just waited, but I thought, okay, I can make a better system. Let's see what we can do. So I have a PowerPoint slides thing I'll try to put them up where you can see them. But in any case, I've got it done. It works really well. The last thing that I'm moaning with here is how to assemble these things. I've gone through several iterations, and I've showed you some of them, where I put the eyelets in, I put wire in, sometimes I press the wire in, sometimes I solder the wire in. You got to be careful when you solder on plastic, because sometimes it'll get real hot, and it'll melt, and it'll kind of deform and not work right. So okay, so I came up with a fixture where I would solder them on a piece of wood. I'd make everything the shape and length and whatnot, and try to solder them up and then fit them in. And I've been doing pretty good. I've got 3 built so far. It's not perfect yet, and it's still a little tricky, and I'm not sure if it's really better than the wire. I'm not sure. The wire was pretty simple, and it did work. Well, in any case, what I start with are these eyelets, as I call them. See if I can get this one out, show you what it looks like in case you don't know. They're used in hobby stuff, mostly for decoration or for putting stuff on a shirt or a pants or something like that. It's sort of like a rivet. It's a rivet that we don't rivet. What you're supposed to do is push it between some material. There we go. Push it between some material, and then you spread the opposite side, and then that squishes it like a rivet. Like when they built the bridges and they'd hammer the rivets in. Yeah. Only this is brass. It's real thin brass. But what I do here is I take a little piece of 22 gauge wire. I put flux on both sides, and I actually solder the wire to the side of the rivet, just like that. I solder that. And when I do that, then I end up with something like this, soldered wire on the end of a rivet. Okay, then we take this out of this particular fixture. This was just the soldering fixture. That's all I used this particular location for, but I have a new method now where I've got the wire soldered to the rivet, and it's in the right way where I like it. I flip it over and I stick it down in this hole as if it's going down into one of these holes on the side thing, and then I bring it over like this, and that's all ready to solder onto my strip. Now this is the center one, so you can see the center one goes over the strip. So then what I did was I took this guy out after I soldered his rivet in place. I took him away, and then I laid him down as if he was on the center. Now I'm doing this in a way that is upside down, so what you're going to see, it looks like this now. Okay, and that's what I'm doing. I'm building this thing up, and what I'm going to do next is solder that wire, and then I'm going to I have a wire here, and I'm ready to solder this wire on, and then take it off and put it over there, and then I'll solder them both onto this brass bar. I'm calling that a bus bar, and it's just a piece of brass that you can solder to easily, and it conducts really good. It could have been a thick wire, but I didn't have any. I thought I had some big bus wire I used for my grounds inside my amplifier for my guitar, but it's somewhere in a box. I don't know where it is, but I did have some metal brass that I used for shims and stuff, and I tested soldering to it, and it solders very well. Sticks, you can't rip it off. So I think this is what I'm going to do. So I solder this up. Then to assemble it, you poke the little wires in, and you run this wire through the top. These are all going to get soldered before I do it. This is the one I built just lately, and it's a challenge, but you can fit it all in, run it up through the pipe, and then you poke it out the backside, and then the backside, we set this down like this in this fixture, this portion of the assembly fixture, and these studs stick up just a tiny bit, and that's how you can get the face plate on. It lines up. You line it up on those two screws, and it fits right down. And then you, in between the two of them, you put super glue, so it glues together. Not like this, but it does glue together, and it comes apart. Then you lift it out, and you're done. So you got the front part and the back part, and there you go. And it works, and they conduct real well. I've got the wheel axle arrangement all figured out now. 7 millimeters, squish them to 16. 3 millimeters sticking out the side. What I did learn was when you're done with your assembly, you need to clean out both the tapped holes that you have. Well, I use these threaded inserts like this, okay? And you need to clean those threaded inserts out with a tap. It's a 440, and sometimes some plastic may work its way up into the threads or get in the way. You got to clean them out. I also know that then when you're done, you need to clean the riveted holes out with a drill to make sure there's no plastic down in the bottom of that, and test it with a piece of axle. That make sure you can get your 3 millimeters in without any interference, because sometimes something will get in there and get in the way. Then you can get your pivot frame together and assemble them with the wheels and axles, making sure you got your 36 inches right, and 29.5 or something like that on the outside of the wheel, and they sit together very nice, and they roll very nice, and it's a good thing. But I really need more feedback on this assembly process. I mean, I've worked, it's like you chase a rabbit hole down, but you know, engineers, they like to finish and conclude and say, you know, there's the answer. And so we do that. And so I did. And I go, there's the answer. And here's where we are at. And this is one of the latest ones. Hey, I don't have any place to flop something down and show it to you. Here we go. I'm going to flop it. Okay. There you can look inside and see the rivet. You see the black. There you can see the black wire inside. These wheels spin really nice. These wheels spin really nice. It has excellent pickup capabilities. Makes the big engine really go well. And I tested all the voltages. There's just a few, maybe 0.3 volt drop because of the wiring, I think, probably. But it brings AC up, converts it over, and it really works well. The wires come up, go to the converter, come back to the motor controller, up to the motor, which is, well, it's a DC conversion. I know. I got magnets for the armature fields. And it runs really smooth. Showed you the other day, I think. But I need your feedback on this assembly. I mean, is it that bad? Is it just we're not going to build them? No one's going to build them. It's a bad design. I'm not sure. I was feeling optimistic yesterday, so I thought, okay, I'm going to come in. I'm going to build 4 from scratch. I'm going to get the process. I'm going to build a little help board, you know, for soldering these things separately and then putting them together, and that'll work out and it'll be great. I don't know. I'm not sure. I'm just not sure. I think when they're done, they're going to be reliable and work well, but gee, my knee. I need other people that are willing and able to build these things, and I'm not sure I'm giving you what you asked for or what you think you can do. Okay, I'll do a few more and then we can talk about it another day. I do have that slideshow. I'll try to put that up. Probably not today, but maybe tomorrow. Okay, fill you in. That's what I'm at. Later.